if now we were to calculate now this sample, that is the sample variance, then we will have to do what? Just a minute, I let someone in. Okay, so if we are now to calculate the that is the the sample variance, okay, we'll say now it is the summation of xi's, okay, minus x bar squared, okay, then we divide by what? N minus 1, okay. So like for from our example, we know that n minus 1 will be equal to 50. It's equal to 50. So or it is 50 minus 1, okay. Or basically we know that this one will be 50 minus 1, so it will be n minus 1 will be equal to what? 49. We know this is the sum, that is the sample size which we are going to use, okay. All right, then the other thing, okay, the other thing is now to calculate the what? This one. So what we'll do, we'll compute that is the xi minus x bar, okay, raised to what? Raised to 2, meaning we have to calculate what we call x bar. And remember in our introduction we said that x bar is equals to expectation of xi's. It is the expectation of xi, okay, or x bar is equal to that is it is equal to summation of xi's, okay, divide by what? Divide by n. Basically this is the mean, okay, the average. So we will need for us to have now the that is the variance, we'll need x bar, okay, we'll need n minus 1, okay, we will need also x i's minus x bar squared, okay. So this is now the mathematical method, okay, or the mathematical approach of variance, okay. So basically what I mean is that in this case we are going to compute that is, we know that is our monthly income, okay, they are our xi's, okay. These are these values, all these values, they are our xi's, okay, they are our xi's. Maybe let me return this to the original data. It was 98,000, yes, before we changed it to 100,000. So basically these are our that is xi's. So we have xi's, okay, whereby I is counting from 1 up to 50, okay. So we have 50 xi's, okay. So we will also need what we call mean, okay. We'll also need maybe average. Let me say we need x bar, okay. And for our x bar it will be that is it will be mean, okay, it will be average of all these values, we know that, okay. Or basically sum of these values divide by what? Divide by the total count of those values, okay. All right, so we already have our x bar, okay, we already have our x bar. So in this case, we want to calculate what we call xi minus x bar. Xi's minus x bar. Then after that, we'll come to do what we call xi minus x bar, okay, squared or raised to 2, okay. And then after that we'll do now the summation of all, we'll do the summation of all this, okay, then divide by the what? n minus n minus n minus 1. So we know that n minus 1 will be equal now to count, okay, count all of all these values, okay, count of all these values minus what? Minus 1. So in this case, it should be 50 minus 1, which is 45. Okay, so now we will need what? We'll need now to compute this part. I hope we are together up to that point, team. If we are moving together, please let me see by show of thumbs up that we are moving together. Okay, I've only seen 2. Okay, thumbs up. 4. I've only seen 4. What about the others? Okay, are we all together? Are we together, guys? Okay, it's my hope we are together. Okay, good. So basically we have our mean, we have our n minus 1. So what we need is to calculate the xi's minus x bar. Okay, so we'll be calculating, these are our xi's. So 5,000 minus our mean, 6,000 minus our mean, 10,000 minus our mean, all that up to the 50th value. Okay, so in this case we are going to say it is equal to this minus this. Okay, but we are referencing where we have the x bar, or we are referencing the mean. Okay, so meaning for this first cell, for the xi cell, we will maintain it the way it is, meaning it is changing throughout the cell, that is the cells below, but we are maintaining what? Or we are referencing this cell D1. So basically, we are going to lock D1. And to lock it, we usually use $sign. On your keyboard, you can do FN, F4, or F4 alone, okay, only. So once you do that, you'll get this value, and then you can now drag that is the value downwards, and it will give you an accurate value. Okay, it will give you accurate that is calculations. Okay, then we have the xi's minus the x bar. Now we need the xi's minus the x bars squared. So basically, we'll square this value. Okay, so we'll say it is that value. Okay, that is xi's minus x bar. Okay, raised to 2. Okay, or we are squaring that value. Okay, then after that you can now drag that is the value downwards. Okay, so these are our what? These are our that is xi's. Okay, these are our xi's minus x bar raised to 2. Okay, so what are we missing now? We already now have okay, we already have this part. We already have this part. This part. Now we are remaining with the summation, and now dividing it by what? Dividing it by n minus 1. Okay. So in this case, we are going now to maybe we can come here and say we need what? The summation. Okay. Summation of that is xi's minus x bar, okay, raised to 2. So that's what we need, and this is our what? This is our numerator value. Okay, so in that case we are going to sum up all the xi's minus x bar squared. Okay, so it will be equal to sum of all these values. Okay, sum of all these values. Okay, so once you sum, you will get this value. This is our summation. So basically now we have this part. We have we have this part, that is summation of xi's minus x bar, okay, squared. So we already have this. Now we need to divide it by n minus 1 for us to get now the value of variance. Okay, so we are going to say now, okay, our variance will be equal to, that is equal to the summation of xi's minus x bar squared, okay, divide by n minus what? N minus 1, which is 45. So basically this is our what? This is our variance, okay? Mathematically computed variance, okay? What about now using that is inbuilt Excel function, okay? We are going to use that is var dot what? Dot sample, okay? Var dot s. Why? Because we are estimating variance based on what? Based on a sample, okay? And we are expecting the outcome or the value to be this, okay? So in our case, we are going to do what? We are going to highlight our monthly household income data and then enter, and you can see we are getting the same value, meaning our mathematical calculation method was what? Was correct. Okay, good. Now what does this value mean? What does this value mean? That's a question to the class. What does that is this value of 681 million mean? What does this value mean? Someone?
Let me try.
Yes.
Could you go back to that figure? Basically, this variance,
Mm-hmm.
from my own understanding, is that the variance measures how the data is distributed
Mm-hmm.
around the calculated mean,
Uh-huh.
which is normally along a single axis. So my assumption is that this variance shows how the 68100 something point one is distributed around our mean in accordance to the sample we have.
That's correct. So basically, what maybe from the definition of the mean, okay, let me start there. From the way we defined our mean, our variance, we say that variance is the measure of dispersion, right, or the spread of the data points, okay, in a data set. That is in a data set away from the mean. So basically variance shows us the dispersion or the spread of the data points, okay, when you compare those individual data points, that is from the what? From the mean, okay? And we know that a higher value of variance, okay, basically tries to show us our data is spread away from the mean. Like basically, we have some people who are earning more, okay, more than average salary, okay. Why? Because the distance between the mean value, okay, and the that is the people who are earning that is the highest, it's very what? It's very large, okay. That's why we are saying that the higher the variance, the more spread out the that is our data points are, okay. If you have a higher value of variance, then that basically means we have what? We have like that is our data points are spread. They are spread out. Okay, they are spread out. That is far away from the mean. Okay, so basically, in our context, okay, that is this variance, it's trying to to represent some statistical measure, okay, of how much maybe individual income data points, okay, they deviate all the spread from the mean, okay. So in our case, this value tries to indicate that there is a significant amount of variability, or there is a significant that is dispersion, okay, in the income in the income amount, or in the monthly household income, okay, within our data set. So basically it is evident, okay. Why? Because we got a that is a that is huge value of what, of variance. So basically here, that is this value is trying to indicate that we have a very significant variation or variability or dispersion, okay, when it comes to the income amount, okay, or we have high difference, okay, between the mean, that is the mean income, okay, amount to the individual what, amounts, okay. So basically that's what this value is trying to do what, to mean, okay. Yes, so you can see even from the value we really have high range, okay, or a wide range of the income amounts, okay, in the data sets, okay. Why? Because even if we examine now, that is the individual data points, okay, we have some significant difference, okay, between the mean and the individual that is data points, okay. All right. Okay, when you are trying to compare the dispersion of values in two columns but with different scale, can we use variance? Variance between two variables. Okay, no, now that won't be variance. We'll be now talking of covariance and that is correlation. So in this case, we cannot that is measure dispersion between two like two columns or two variables. Okay. Yes. Yes, Jennifer.
Yes, good evening.
Good evening.
Actually, I have two questions.
Mhm,
One says,
mhm.
how would be the how big would be the variance to say that that variance is big?
Okay, so for that first question, it depends with the data. Okay, so the less the value, that's why I said when it comes to covariance and variance, okay, and also we'll also learn when it comes to standard error. Okay, the more close to zero it is, the smaller deviation we have. Okay, but the far away from zero the value is, okay, it is what, it is that is it has a very big what, a very big variance, okay. So can you compare, maybe try to compare a variance of now this almost 1 billion and a variance of 260 or 230, okay. So in that case we can say that the data, okay, the data points, like for this one, we it is clearly that is the data points, okay, they are spread away from the what, from the that is from the data set, like sorry, from the mean. Like for example, let me try and see, um, but that would give me the accurate, because here it's only one variable, okay. So basically the value that is the larger the value it's away from zero, okay, or close to zero determines the kind of variance we are talking about. Okay, that's okay,
So,
Denver.
so from that variance that we've got from that data set,
Hmm.
what would be our conclusion?
So,
Can we say
uh-huh,
can we say
hmm
can we say that the income for these people in our data set is different? I mean, people are getting different incomes, or maybe there is another inference we can get from
so
it.
what we can say here, like we don't have uniform distribution in terms of income. Like we have some people who are earning that is more or less income compared to the what? To the average income. Okay, and also we have some people earning more that is far away from the average, because remember that the average it's around here. Okay, the average value it's around here, the average income it's around here. So you can see we have some people who are earning that is more away from the average amount. Okay, the same way we are having some people who are earning that is far less. Okay, in comparison to what? To the average amount. Okay, so imagine you are comparing someone earning that is 40,000 with someone earning 5,000 and another one earning 100,000. Okay, so you can see, even if we were to plot this, some of the data points will be far away from the what? Will be far away from the mean. So basically that's what this is trying to what? To conclude. Or what we can say, this value definitely indicates that there is a significant variability, or there is significant difference in what? In individual that is income amounts within what? Within these data sets. I don't know if that was clear, Jennifer.
Yeah, it's clear.
Okay.
Then the other question that I have, but I don't know if it's an aside one, or maybe we tackle it maybe at some point in this class.
Hmm.
Let's suppose we have a seller X.
Sorry.
The let's suppose we have a seller X, or maybe any seller.
Uh-huh.
Then that seller buys goods and sells those goods.
Hmm.
So that means you have two variables. You have the variable of bought goods and the variable of sold goods.
Hmm.
Um, I was wondering which statistical measure can we use to check whether those two variables grow into the they grow into the same direction. I mean,
Good. Good. Your question,
all
your question already as an answer. Like we are trying to see now the covariance. You are trying to correlate between that is the two values. The way maybe we will go to will come and correlate that is the the relationship between what? Between the income of that person and the way they are spending. Okay, like the expenses. Do we really have a relationship, or in what direction maybe will be the movement in terms of maybe whatever increase the monthly income of this person, how will the what? The expenses behave. Okay, so basically there we'll talk about what? We'll be talking about now the covariance. Okay, but now for the variance, we only consider one what? One variable only. Okay, but for covariance, correlation, now we are talking about what? We are talking about two what? Two that is two variables. Okay, and with that we can compare But for variance, you cannot compare two variables. I don't know if that's clear.
Yes, sir, it's clear.
Okay, good. We have someone asking what is the difference between covariance and coefficient of variation. Covariance, and coefficient of variation. I don't think if we have that is any that is a difference. Okay, I don't think if we really have any difference between these two uh, variables. Okay, all these two terms, they are all the same uh, variables. Sorry, terms. Okay, all the same. Yes, let's say the same measures. Okay, they are one and the same thing. They are one and the same thing, because they are trying to we are trying to compare now that is the mean, okay, with the standard deviation. And if you check maybe the formula, you can try and google the formula. If you check the formula, you might have what you might end up using the same formula. Okay, you might end up using the same formula, but you can confirm that, and in case of any maybe difference, we can do what we can check, but I don't think if we have any difference between the two. It's the same as when we are talking about when we'll be talking about uh, what do we call it the measure of goodness of fit and the coefficient of determination. They are the same things. Okay, or the coefficient of correlation and the multiple R, they are the same thing. Okay, all right, so I hope we are together. That is up to variance. Any question up to that point before I can go now to standard deviation? If you have question, you can unmute and ask. If we are all together, thumbs up so that I may proceed. Awesome. Good. Now let's go to standard deviation. What did we say about standard deviation? So for standard deviation, we said basically it's the what? The square root of, we said it's the square root of variance. So in this case, we are going to assume that is standard deviation is square root, SQRT, okay, square root of variance. Once you compute that, you'll get this value. You can also use that is an Excel inbuilt function, okay, an Excel inbuilt function called stddev or stdev dot what? We have population and we have sample. We are working with what? Sample. stdev dot s, or for sample data. Okay, and then you will highlight the same what? The same that is data. Okay, data range, and you can see you will have what? You will have this, you'll have the same values. Okay, will have the same value. Now when it comes to standard deviation, what does this value mean? What does this value mean? What does this value mean? Someone? It is more of basically it is almost sharing, that is measuring, or the same thing which variance is measuring. Okay, the difference is that it's because maybe the standard deviation is trying to show uh, at what extent is the what is the dispersion, at what extent is the dispersion. Okay, so basically maybe let me take you through this. So basically we know that standard deviation, of course, is also a statistical measure, and now it quantifies the extent, okay, or quantifies the extent to which now the individual data points, okay, in a data set deviate from the mean. Okay, it tries to quantify, okay, the extent to which maybe an individual data point in a data set will deviate from the what? From the mean. Okay? Or it is also measures what? It is also measures that is a dispersion of the data. Okay? So basically, in our context, we know that the standard deviation of this, that is this value, tries to show us that the income amounts, okay, indicates the average amount of variation, or it shows us the average amount of what? Of dispersion, okay, in our data sets from the what? From the mean. Okay, it is trying to show us the average deviation or the average variability. For variance, it was trying to show us if there exists, okay, if there exists a variation, okay, and we saw that yes, there exists a variation, and it's not only a variation but a significant variation, depending with what, with the value which we got, okay. But now for the standard deviation, okay, tries to quantify to which extent, or tries to indicate the average amount of variation or the average dispersion in our what, in our data set from the mean. Okay, so basically here, of course, our standard deviation is also high here. You can see it's a value of 26,000. Okay, it is also that is a large value. Okay, and also basically the moment you get variance, which is that is of a big value, so do you expect standard deviation to be also what? To be also of a, yeah, that is a big value. Okay, so basically also here we can say that is we have a higher standard deviation, okay, or this higher standard deviation tries to show us that the data points are more spread out from the what, from the mean, as we saw in what, in variance. But now for the standard deviation, basically it's showing us the average amount of variation. Okay, then how can we conclude, or what inference or conclusion can we get from that is from our context? Okay, so basically in this context, the value of or this value of standard deviation suggests that there is a moderate to high, okay, let's say moderate to high variability. We have a moderate to high variability when it comes to income levels within the data set or within our data set. So there is a moderate to high variability, okay, when it comes to the income levels in what? in our data set. Or what we are trying to mean in layman's language is that some individual income amounts, okay, are significantly higher or lower than the average income. Okay, that is the income, they are significantly, okay, the individual incomes, they are significantly lower or higher in comparison to the what, in comparison to the average income. Okay, and basically that is the standard deviation here will give us now the measure of how these incomes they deviate from the what, from the average. Okay, I hope that was clear. I hope that was clear. Yes, Brian?
But, but, but sir, not always. It
Hmm.
helps, but not always.
Sorry, what?
I may say that the mean and the standard deviation,
Hmm.
it helps, but not always.
Okay,
Because, for instance, in that case that the data that we may deal with, we have an assumption that there is no outlier. In the case that we may have outlier, it could be good practice to eliminate the outlier
outlier.
first so that you can rely on those results.
Yes, yes. Now this is based on the maybe the data we have available without what? Without eliminating the outliers. But if we were to clean out and eliminate the that is the outliers, then you would get that is that is a less value when it comes to the variance and the what, and the standard deviation. Why? Because they will be almost within the same range of values. Okay, so like we won't be having a high variance or maybe that is a high standard deviation, but they will be averagely within what, within or around the what, the value of the mean. That's okay. I mean, that's what you are trying to mean.
Yeah,
Okay.
sure, sir.
Okay.
Thank you for the explanation.
Okay.
Because I think that what came to solve with the distribution,
Mm,
whereby if maybe we have like the number 2, 4, and 5, and
mm,
if we introduce maybe 500, one number to be 500,
mm.
we're
We
like
adjust
misleading
or
the
we yes,
interpretation.
correct.
The variance we're misreading the interpretation. So I think that yeah, the distribution can come and then isolate the outlier from the normal data that are real in the nature.
Correct. Yes, Brian, you have a question?
When you said moderate to high,
Hmm.
what did you mean?
So basically, I said it's that is the value. It's higher than the what? The value it's higher than the that is or maybe basically let me just rephrase it. Okay, you can say we have a high that is variability instead. Okay, when I'm talking about moderate to high, it means like it's no longer maybe that is a small or a lower variability. Rather, it's what, it is high, or it is increasing, or it's moving from the what, from the low or from the moderate to high. Okay, so basically in short it is high, it is showing high deviations. Okay, it is showing high deviation. Okay, yes.
What is high?
High basically means like
High,
we
high.
have,
You said moderate to high.
yes. So high, basically what I'm saying is that we have high variability. High variability is that we have high deviation or high, that is high difference, okay, between what? Between the highest income value and the what and the mean that is the mean income value. Like for example, let's check on this. Okay, our mean value is what? It's within this. Okay, it is within this. So let's assume maybe this was our data set. Okay, and it's going up to this point. Okay, basically you know that the values around that is the around the mean. Okay, they have no that is large variability or difference. Okay, but when we are increasing now the value of the income, we are now moving from maybe moderate, meaning it's within the like plus or minus let's say 1,000. Okay, but as we are moving, you can see that the dispersion or the variability is also increasing. Okay, why? Because we are comparing the individual data points with the what? With the average. So that's why I said it's moving from moderate to that is high difference. Why? Because you cannot compare the difference between 45,000 and 41. Okay, and that is at 100,000 and 41 to be the same value. But what I'm trying is that the variability it's moving, okay, from maybe moderate to high that is to high variability, from a small difference to a big difference within the mean. I don't know if that is clear.
Oh,
Or
I think I've understood.
yeah.
I thought you meant I, letter I.
No. It is high, high with H, high.
Oh,
Or you want me to
man.
say high? Okay, yes, high.
Sawa sawa.
All right. Okay. I hope we are clear. That is on that point. Yes.
Sorry, I have a question. It's a follow-up question to that of May. Like, I was wondering which step to take first. Is it like we do descriptive statistics and get these values, and then we question the data that we have, or we first arrange the data, we pass through it, and we find outliers, we remove them, and then do the descriptive statistics? Like, I'm not getting which one to start with first, because I was thinking that from these statistics we will get like the information of what's going on, and then think of, like, from the value we can think of why is this happening, and go back to the data and see what's really happening in the data set. But now, if we have to first remove the outliers, then how are we going to identify those outliers before we make those descriptive statistics?
Okay. Thank you. So, according to the nature, okay, according to the nature of the data, this data, you can see it is monthly income, okay, for each individual. Let's assume in this, in this, like, in this class, okay. So basically, we are trying to that is to get some insight. How is our salary distributed here? Is it fairly distributed? Okay. So if that is our objective, to see that is how our salary, okay, are distributed here, then we don't need to remove what? We don't need to remove that is the outliers. Why? Because now we want to see, is it true that that is our salaries here are not well distributed? Okay, but if it was more of a research question, or it was more of a maybe research work, okay, whereby maybe you are you've collected some data, okay, and you want to come up with the best, maybe a best model all the that is the best reliable that is a statistical measure, okay, then you will have to remove what? To remove those outliers. Like for example, okay, if you were going to do a research on maybe a certain what? A certain maybe lotion or a certain cosmetic, okay, maybe in the market. That's a product, okay, of that cosmetic, okay. So basically, you will have your target population, okay. Maybe you'll be targeting that is youths, okay, or persons with what? With age between 25 to 35, okay. Maybe that's your targeted population, okay. But maybe you when you were collecting data, you came maybe across, you also did that is you collected data for odd maybe from the old people or from the children who might not be using that product, okay. So in that case, for you to get like the now the that is the more significant conclusion, you might now consider to use people or responses from people with age between who are aged between 25 to 35 years, okay, meaning anyone who is aged 70 years or anyone who is aged 10 years, okay, will be an outlier to your research, okay. So you will basically remove those outliers, okay. So for that, for you to get now that that is your the best conclusion, you will first of all remove the outliers before you can what? Before you can now do the descriptive statistics, okay. But this in this data, our objective is to see in this class, okay, how our salary distributed. Very simple, okay. Meaning we don't have like a research topic on the same, but we have more of an objective to check what? To check how our salary are distributed. Do we have high variance between each individual what? Salary, okay. So basically that's the difference. I don't know if that was clear.
Yeah, it's clear. Thank you.
Okay. Okay, good. So I'm going to now move to the that is the covariance, covariance, covariance part. Okay, and for our covariance, I want us to check if we have any that is any relationship. Okay, between what? Or what kind of relationship do we have between income and our expenditure? Okay, or how does our expenditure, okay, how do we behave, okay, when, or what is the like consumer behavior when the income increases, okay. Does it mean when income increases, the what? The expenditure also increases. When the income decreases, does it mean the expenditure will also decrease? Or does it mean whenever maybe the income increases, there is no change in what? In expenditure. Okay, so that's what we are trying to check here. Okay, or how does change in income? Okay, how does change in income influence that is influence what? Influence the expenses. Just a minute. Okay, good. Sorry for that. So that's what we are trying to do. What we are trying to check here. Okay. And if you can remember from our, that is from, it was from our formula. Who can remember the formula for covariance? Who can remember formula for covariance? Okay, let me remind you. So for covariance, we said that covariance is given by, that is covariance of variable x and variable y, meaning here now we have one variable and the second variable, or let's say the household income and household expense. Okay, it will be given by summation of variability in what? In the household income, okay, to its mean. So that is xi minus x bar. We will not square, okay, multiply by that is the variability between what? The expense income minus what? Minus the that is the expense average. Okay, then we'll divide by n minus what? N minus 1 if it is for, sample data. Okay, then for correlation, remember we said that it is the covariance of x and y divided by standard deviation of x multiply by standard deviation of what? Of y. So basically, it is these divided by what? The standard deviation of the two variables. Okay? All right. Good. Now let's go to, that is the practical part of it. So in this case, we are going to compute xi, okay, xi minus x bar and yi minus y bar, okay, divide by what? Divide by n minus what? Minus 1. Okay, all right. So this will be our xi, this will be what? Our yi. Okay, so basically what we need here now, it is the income minus the income mean, that is the xi's minus x bar, or let me just write it in that format, xi's minus x bar. We also need yi minus y bar. Okay, so in this case we want to compute x bar, and our x bar will be equal to, let me enlarge this so that it might be visible on your side. So it will be, our x bar will be equal to average of the income amount. Okay, then that is our y bar will be equal to average of our monthly expense. Okay, so this is our what? This is our x bar, and this is our y bar. Okay, so meaning now we can compute what? We can now compute this. So it will be equal to our x i's minus our x bar, which is this one. Okay, just a minute, I want to change something. Remember here, we initially had a 98,000. Okay, yes, so it should be, okay, it should be like that. Yes, the same value. Okay, the same value. Good. Now let's continue. So here it will be what? That is that is the xi minus the x bar. Okay, so definitely we'll have to lock what? We'll have to lock g1. If we won't lock g1, okay, you can see what will happen. Like if I am that is doing what? Computing, you can see it is referencing cells which don't have what? Don't have the average. Okay, so basically I'm going to what? I'm going to lock our x bar value. Okay, then once I lock, sorry, I will lock our x bar value, then enter. Then after that I can now drag it up to the end. Okay, and this is what? Our xi minus x bar. What about our yi minus our y bar? It will be that is the expense values divided by the expense average or mean. Okay, the same, you lock the cell where we are having the average for that is for the yi's. Okay, and drag it down. So basically we are done with what? We are done with this value and this value. Okay, so the next value we need, it is now xi's minus x bar. Okay, this is the mathematical computation, multiply by, okay, yi's, okay, minus y bar. That will be our that is the other calculation we'll do. So basically it will be this multiplied by this. And since whenever we have some negatives, then they will cancel out. Okay, that is a negative multiplied by a negative, you'll get a positive. Okay, all right. So after that, okay, after that now we'll go to the next part. I want us to finish with the numerical. So that is the numerator. Sorry, the numerator. So now we will now compute what? The summation. Okay, we know that is n minus 1 will be what? Will be 49. Okay, so in this case we'll come here and compute now summation of, we will need now the summation of this. We'll need now the summation of this. Okay, so it will be equal to sum of all this. Okay, and now we have now the n. We have n minus what? N minus 1, which will be equal to 50 minus 1, which is 49. And then we can now compute what? Our covariance. We can now compute our covariance. Covariance will be, that is our covariance, will be now equal to the summation of xi's minus x bar multiplied by yi minus y bar. So it will be this value divided by what? By n minus 1. So we're going to get this value. Okay, we are going to get this value. So remember, I said for covariance we can get even a billion value. Okay, we can get what? A value which is billion. Okay, so what does this value mean? Someone?
Can I try?
Yes, you can try.
I think
Uh-huh.
for covariance, it mainly measures the directional relationship between the two variables.
Mm-hmm.
And when the uh, when it's negative, when
Mm-hmm.
the direction is negative, we say it's inverse relationship. But when it's positive, it becomes a direct same direction. It means we have a positive covariance.
Mm-hmm.
So because our covariance is positive, I would say uh, we have a positive covariance, or we have a positive correlation between these two variables. That is between the income and the expense. An increase in income would lead to an increase in the expense,
Okay.
kind of.
Okay, yes, that's a good trial. Someone else? Someone else? Jane Van, do you want to try? Brian?
The relation between the two are strong.
Strong. No, when we talk when you now include strong, you are now going to correlation.
Uh,
Remember, we said covariance basically shows us now the direction,
oh yeah, yeah.
or the degree of change. Okay, so maybe let me just help you in this. So just to yes, aim.
I would say that the expenses and the income, they
Mhm.
change in the same direction. And
Okay,
in the nature, it means, yeah, in the nature of the two variables means that the expenses depends on the income. If the income goes high, also the expenditure will also go high. So the two variables goes in the same way. That's
okay,
what I would say.
okay. All right, all right. So basically, if you can remember, we said that this is how we defined covariance. We say that covariance measures the joint variability, or measures the variability, or direction, that is directional relationship between what? Between two variables. Okay. If you can remember that, we say that for a positive covariance, basically indicates that, like, one that is one variable, okay, that is it's above maybe its mean, okay, and the other variable, okay, also might be typically above what? Above the mean. That is more so for a positive correlation, covariance, sorry. Okay, so basically covariance, we say that is a statistical measure that will indicate the degree to which two variables change together. Okay, so now in this context, or in a context where we are checking that is the covariance between the income amount and the expenses. Okay, this value which we've gotten, okay, this value which we've gotten, it is what? It is a positive value. Okay, try which basically tries to indicate, or which indicates that we have a positive relationship between what? Income and the expenses, meaning that on average, an increase in income, okay, triggers an increasing what? Triggers an increase in the expense. Or whenever income increases, expenses also tend to what? Tend to increase. Okay, so basically that's what this means. Okay, that is the people's income. Okay, or the employees' income tend to increase. Okay, that is or the employees' income or the employee's expense, let me reframe it. The employee's expenses tend to what? To increase with increase in what? In income. Okay, that's what it is trying to show us. Okay, that is an increase in income will bring a positive maybe change. Okay, or will trigger maybe also an that is a positive change to the what? To the other variable. That is, if the income is increasing, then the what? The expenses will what? Will tend to increase. Okay, yes, so basically that's what this value means. Like, they are moving in the same direction. Okay, when one variable is increasing, the other variable is increasing as well. Okay, all right. So I will reach there for today's or I will stop there for today.